Hello, beautiful people, and welcome. In today's video, we are going to be talking about arithmetic series and specifically determining the number of terms in each arithmetic series. So before we do that, let's talk about what we did yesterday. And yesterday, we evaluated the series. And I want to be very specific about the instructions because sometimes it gets you as okay, well, what am I trying to find? If we are evaluating a series, we are finding the summation. So let's do a quick example of what we did yesterday before we move on to what we're doing today. So yesterday, we were given sigma. Remember, sigma is a pointy E with teeth. And we had an upper limit. We had a lower limit. We had an explicit rule that was provided to us. And we were asked to evaluate the arithmetic series. Now, before we even did anything with a formula, I asked you to find three things. The first thing I asked you to find was your total number of terms. And to find that, there was a little formula. We took our upper limit minus your lower limit, and then we added 1. So for this example, our upper is 14 minus our lower is 4. We're going to add 1 to that. So 14 minus 4, that's 10, plus 1, that's 11. So we have our, let's keep it colored, 11 as our total number of terms. So that is our NT. Now, I do a subscript of T for the total number of terms. It is not this N that they're giving to us. Be careful. There's a lot of N's sometimes floating around. All right. Next, I asked you to find the term in the first position. And the term in the first position actually refers to the term in the lower limit position. To find the term in the lower limit position, you're going to take the explicit rule that they give you. You're going to copy it down. You're going to open it up for n or whatever variable they give you. Again, please do not get confused as to what all of these n's are. The n they are talking about here is just a variable. A variable is just a letter that represents a specific number. For us, the variable of n here in the equation represents the lower limit of 4. So we are going to type that into the calculator or do it by hand. We got 10 times 4, which is 40, subtracting 12, we get 28. So the term in the lower limit position is 28. The third thing I asked you to find is the term in the upper limit position. So term in the upper limit. And you can already see that I highlighted. So we're going to write our equation, technically explicit rule that they provided. Open up for n, and now instead of putting in our lower limit, we're going to put in our upper limit, which is 14. So 10 times 14 minus 12, and I get 128 as the term in the upper limit position. Now, in our formula, you won't see a lower limit position, you won't see an upper limit position. Instead, what the formula provides is, I'm going to put this in quotations, an a sub 1 and an a sub n. So in the equation for the summation, we are going to be replacing a sub 1 with the term in the lower limit position, and we're going to be replacing a sub n with the term in the upper limit position. Now let's write out our formula. The sum of the total number of terms. Again, you won't see this T in your textbook or any other class. T is just something I'm doing to help you realize that this is the total number of terms. That is equal to the total number of terms divided by 2 times the term in the lower limit position plus the term in the upper limit position. Let's go ahead and fill this in. Total number of terms was 11. Total number of terms is 11 divided by 2 times the term in the lower limit position is 28. The term in the upper position is 128. When you type this into the calculator, please make sure to put parentheses around fractions. If they are not able to be solved by hand, I usually just type it in anyways. So I'm going to type in open 11 divided by 2, close, open 28 plus 128, close, enter, and I get 858. Now, how do you write your answer? It has to be as a sentence, a mathematical sentence. The sum of 11 terms is 858. This is how you write the final answer. You must have it as a sentence in math language. Okay, this is what we did yesterday. We evaluated each series. Let's move on to today. For today, they will already provide us the summation. They will tell us when we add, it's going to be this number. What they won't tell us is how many numbers we're actually adding together. So determine the number of terms n in each arithmetic series. Okay. Example. Let's start off with sigma. So the sum from an unknown upper limit when the lower limit is 1 and our explicit rule is 4k minus 2 equals, so it's very different now, equals 3,200. So let's talk about what each little piece is. Ooh, just dropped my pen. The upper limit is now unknown. The lower limit is now going to be 1. So your total number of terms is your upper minus your lower plus 1. So when you have a lower limit of 1, this n ends up being your total number of terms just because of the formula. Next, you have your explicit rule. Then you have your actual summation. This is your S sub n. This is your, after you've added a certain quantity of numbers, this is the total sum. Notice that I did put S sub n because we don't know how many terms we've added together. If we take our previous equation, so I'm going to separate this out. S sub n is equal to n. I'm going to keep writing n because that's now the total number of terms, divided by 2 times a sub 1 plus a sub n. There's certain things we don't know. We don't know what n is, but I do know what S sub n is. S sub n is the total sum. I have the total sum. Do I have how many terms I'm adding? No, that's still unknown. Do I have the term in the first position? Well, I can put the lower limit in and solve, yes. But do I have the term in the upper limit position? No. So because I don't have the term in the upper limit position, we're going to have to go back into sequences, not series, sequences, that's the first lesson we learned, and use a sequence formula to find what a sub n is. You ready? A sub n is equal to a sub 1 plus d times n minus 1. I know it's been a while. I had to think about it as well. This is your sequence formula. This is your series formula. Think of it this way. S is for sum. Okay? When we find the sum, we're talking about series. This has a common difference. When we find the common difference, we're talking about sequence. All right. Now, if we take a look here, obviously a sub n is unknown because it's unknown here. We can find a sub 1, but what about the common difference? Common difference is taken or pulled out of the rule. So we have the common difference, and that's always going to be attached to the letter or the variable in that equation. Okay, so let's take a look at what we have. I'm going to switch colors here. If we take our sequence formula, a sub n is equal to a sub 1 plus d to the n minus 1. I still need to know what a sub 1 is, so I'm going to take the lower limit. A sub 1 is equal to, copy down the equation, open up for 1, or k. K is now 1. Remember, this all matches. We're putting in lower limit. 4 times 1 is 4 minus 2. It is 2. So the term in the lower limit position is 2. Okay. So if we put this into here, I want to show you what happens. Let's bring it here. We got a sub n, also unknown. A sub 1 is now 2, plus common difference is 4, times n is still unknown, minus 1. And I'm just going to keep writing it here. I know it's going to be smushed, but you'll see. We don't really need that much space. Distribute that 4. We got 2 plus 4 times n, minus 4, combine like terms. A sub n is equal to, what's 2 and a negative 4? Negative 2. 4n minus 2. I'm going to put this in a thinking bubble, and I want you to take a look around your summation, your sigma, and see if you can see something that resembles. If you take a look here, do I have another highlighter? Probably not. So let's go ahead and just circle it. Take a look at your rule. Take a look at your a sub n. Notice the similarities. Notice the differences. For the difference, they are not using n. They are using k. For the similarity, everything else is the same. We got the 4. We got the negative 2. So we can replace a sub n with our rule as long as we change the variable to an n. Or you're going to have to be doing this, which we don't want to do that. All right, so let's go ahead. I'm going to rewrite this so we can actually do some solving. I thought I wasn't going to have to pick up my marker. I am. Give me a second. Alrighty, I'm back. Let's go ahead and rewrite this. It's the same example. We have an unknown upper limit. We have k is equal to 1. We have our explicit rule. And we have our sum. You are going to rewrite the formula S sub n is equal to n divided by 2 times a sub 1 plus a sub n. Okay, we already solved for a sub 1 here, so we know that a sub 1 is 2. S sub n, let's erase that because we do know what a sub n is. I keep saying I apologize, it's S. S sub n, the sum of the terms. The sum of the terms is this guy right here, S sub n. So S sub n is 3,200 is equal to n divided by 2, n is unknown. A sub 1, what is a sub 1? A sub 1 is positive 2 plus, okay, now watch what happens. This is the tricky part. You're going to take this equation, you're going to bring it down, But instead of writing k, you're going to write n. That n kind of magically happens, and that's okay. It's the same thing. Just write it as n. We need n. All right, watch what happens combining like terms. We got 3,200 is equal to n divided by 2 times 4n. This is 0. Does not always happen. Doesn't always happen. This is just a happy accident. Okay? Now, pay close attention to this step because this is where things get weird. You are going to not mess with this. You are going to multiply both sides by 2. Okay, why do I do that? We have a 2 in the denominator. We have a 2 now being multiplied. Divided by 2 times by 2. These 2's undo each other. So what you're left with is 2 times, what is that? 6,400, 3200 times 2. Yeah, 6,400 is equal to n times 4n. The 2's go away. Multiply, this is not a binomial, this is a monomial. N times n is n squared. And now you're going to have to solve by factoring or by solving by taking the square root. So here, this is multiplication. I'm going to divide by 4, divide by 4. N squared is equal to 6,400 divided by 4. I get 1,600. Taking the square root. Now, here's something that I want to point out. Whenever you take a square root, it is a plus or minus of that value. And so on the calculator, we're going to do second x squared for the square root. You can't see that. So second x squared, 1,600, and we get 40. So n is equal to plus or minus 40. Now, what does n represent? N represents the total number of terms. So n can be 40 or n can be negative 40. But if I am asking for how many numbers am I adding together, I can't say I am adding a non-existent 40 numbers together. Either they exist or they don't exist. So because this number is negative, this does not work. We need a whole number and we need it to be positive. We need a whole number that is positive. If it is not a whole number, if it is not positive, if it's negative, that means it is excluded, it's extraneous, it doesn't work. Okay? We cross it out. A lot has happened in this example. I understand. Let's go again. Another example. Upper limit is unknown. M is equal to 1. The rule is 10 minus 2m, and the sum is negative 220. First thing you're going to do is find the term in the lower limit position by copying down the equation or the formula that they give you, the explicit rule. Don't write this down. This means something else. Just the inside. Okay. Then you're going to open up your m, put in your lower limit, which is 1, and we're going to solve. So 10 minus 2, we get 8. What does that mean? The term in the first position, in the lower limit position, is 8. Next, you're going to write out your formula. S sub n is equal to n divided by 2 times a sub 1 plus a sub n. This right here is your sum of your terms. So S sub n is negative 220. n is unknown. A sub 1 we said was 8. And, okay, watch again. You're going to take this equation, this formula, and you're going to replace a sub n with it. And you're going to change the variable m to an n. And then close it. Next, you're going to combine like terms, so 8 and 10. And you can put, I'm going to rearrange this as negative 2n. 8 plus 10 is 18. Again, do not do anything here except multiply both sides by 2. That way you can get rid of the fraction. We don't want the fraction. We get negative 440 is equal to n, negative 2, this is times, negative 2n plus 18. Here we're going to distribute and end up with a quadratic. So unlike the other example, this one ends up needing to be factored after we add 440 to both sides. So 0 is equal to, let me shift this up, negative 2n squared plus 18n plus 440. Immediately I am doing a happy dance because I am seeing that I have a 2, 2, and 2 that can be removed. Now here's the thing. You can remove it as a GCF or you can just divide everything by 2, negative. So I'm going to divide everything by negative 2, including, just like we would on a regular equation, all the terms including the 0. So we get 0 is equal to, if this makes you uncomfortable, just pull it out as a GCF. N squared minus 9n minus, no idea. Actually, I do. We just did that. It's going to be a positive 220. Negative 220. Yep. And so now here's where we use guess and check. Guess the numbers that multiply to 220 but add up to a negative 9. So we're going to go into our calculator. 220, we want a negative. Then we're going to start dividing. And so I chose 20 because I saw 20 in there. But 20 and 11, 20 minus 11, that does. So lucky guess for me. It really is a guess and check. The only reason I chose 20 because I saw 20 in there. So let's do n and n. So let's do, we want a negative 9. So negative 20, positive 9. Now, when you're solving, this is now using the zero product property, meaning we're going to set this factor to 0. We're going to set this factor to 0. This was not a rainbow method, so no need to divide anything. I'm going to add 20 to both sides. N is then 20. I'm going to subtract 9 both sides. N is negative 9. Now, these are the two options for our answer. The two options are either a positive 20 or a negative 9. Both of them are whole numbers. But we cannot have a negative possibility because this is negative. This is not an option. So the quantity of numbers that we add up is 20. All right, beautiful people. I would like for you to practice. Try your best. If you're in my class, you do have an exit ticket on this. So please practice. This is a difficult question. Okay? So main things to wrap up, to remember. A sub 1, you put your lower limit into your m to find a sub 1. Next, your a sub n comes from the given explicit rule that they provide for you. After you combine like terms, you're going to multiply by 2 both sides. Distribute just the n. The 2 is going to be gone. The fraction is going to be gone. Then move everything to one side. Solve by factoring. Thank you so much for your time. Go ahead and start your practice.